Taking the square root reverses the process of squaring a positive number. For example, the positive number 3 can be squared or multiplied by itself to get 9. Taking the square root of 9 reverses this process. Because the number inside of the square root symbol can be written as a positive number times itself, or a positive number squared, this square root expression equals that positive number, 3. In a second example, the positive number 10 can be squared to get 100. Taking the square root of 100 reverses this process to get 10. So, squaring a number and taking the square root are inverse operations when a positive number is squared. Note, by convention, the square root symbol generates only a positive value for the square root of a number. This convention ensures that there is only one output for a square root expression, such as the square root of 100 equals 10. The negative square root symbol can be used to reverse the process of squaring a negative number, where -1 is multiplied by the value generated by the positive square root to find its opposite. Finding the square root of a number is related to finding the side length of a square when the area of the square is known. For example, a square has an area of 25 units squared. The side length of this square is 5 units because 5 squared, or 5 times 5, equals 25. When the process of squaring the length of the side to find the area is reversed, the square root of the area is taken to find the length of the side. So, the square root of 25 is 5 because the side length of a square with the area of 25 units squared is 5 units. The square root of a perfect square is a positive integer. A table of perfect squares can be created by listing the positive integers for the length of the side of the square and the perfect squares for the area. The values in the bottom row of this table are calculated by multiplying a value in the top row by itself. Finding the square root of a perfect square is the opposite of this process. For example, the next perfect square is 64. A number that is multiplied by itself to get 64 is 8. So, the square root of 64 is 8. The solutions to the equation x squared equals p, where p is a positive rational number, are represented using the positive square root and the negative square root. For x squared equals 16, both x equals 4 and x equals -4 make this equation true. Because x equals 4 is the positive solution, the square root of 16 is 4. The negative solution to this equation is represented by the negative square root of 16, which equals -4. Notice that the square root symbol, the radical, always generates the positive solution to this equation and not the negative solution. To represent the negative solution, the square root expression is multiplied by -1.